Good day, everyone. Welcome to our TLE 7 class, quarter 4, week 7. Today we are going to interpret the readings in different measuring instruments. By the end of the lesson, students are expected to: Number 1. Explain the function and uses of tachometer, oscilloscope, and ampere meter. Number 2. Identify the parts of the tachometer, oscilloscope, and ampere meter. Number 3. Interpret the readings of tachometer, oscilloscope, and ampere meter. Before we dive into details, I'd like to ask, have any of you seen your grandfather, father, uncle, or elder brother using a multi-tester at home? A tachometer is an instrument that is used to measure the working speed of an engine, usually in revolutions per minute, RPM. It is commonly used in cars, boats, planes, and other types of vehicles. Most tachometer gauges have either an analog or digital display. For the types of tachometer: Number 1. Analog tachometer. It is used to count the RPM based on the period. It uses a series of reads that helps in detecting the engine speed. It is a device that has all centrifugal force. It has a power on the rotating mass that helps in extending and compressing the mechanical spring. Number 2. Electronic tachometer. An electronic tachometer is a significant component that helps measure the engine's speed in RPM. It is a device that is available in the car's dashboard to measure the driving speed. This device uses a magnetic pickup that you can find here, the rotating engine. It produces electric pulses. The pulses that this device causes has a frequency proportional to the engine speed. For the parts of tachometer: Number 1. Contact measuring device. It is a key part of the whole tachometer. Number 2. RPM adapter. It is the element that contacts the object the speed of which you want to measure. Number 3. Function switch. It is used to switch between the units of measurement. Number 4. Memory call button. It is used to show the last reading. Number 5. Display. It shows the readings or result. Number 6. Measure button. It is used to start the measurement. Number 7. Battery cover. It is used to cover and protect the battery from dust and any damage. For class sharing: reflect on your own vehicle experiences. Based on what we discussed today, do you think tachometer displays an important role in our daily living? Recall the time when you observed someone driving a vehicle. How did this lesson impact you as a person riding any type of vehicle? For our lesson activity, students will portray as a vehicle operator. As an operator, what will be your plans to be done before driving or operating a vehicle? List down your answers on the space provided. Moving forward to day 2, we'll be discovering the basics of oscilloscopes. Get ready to learn about this vital instrument and its applications. What is oscilloscope? Formerly known as an oscillograph, informally scope, oscope, or oscope, is a device that graphically displays electrical signals and exhibits how those signals change over time. It measures these signals by connecting with a sensor, which is a device that creates an electrical signal in response to physical stimuli like sound, light, and heat. The oscilloscope, an indispensable piece of equipment in signal analysis, helping engineers reveal the hidden rhythms of electricity. For the parts of oscilloscope: Number 1. CRT, or cathode ray tube. Acting as the heart of traditional analog oscilloscopes, the CRT generates electron beams to create visual displays of waveforms. Number 2. Display. Whether a phosphor screen in analog scopes or a digital LCD in modern ones, the display translates complex data into visual waveforms that engineers can interpret. Number 3. Vertical system. This part controls the amplitude of the signal, allowing adjustments to how the waveform stretches or compresses vertically on the display. Number 4. Horizontal system. Governs the time base and allows engineers to control the horizontal scaling of waveforms, essential for examining frequency and time relationships. Number 5. Trigger systems. Ensures stability and clarity of the waveform. The trigger systems detect specific events in the signal, providing a stable and repeatable display. Number 6. Probes and input channels. Acts as the link between the circuit under test and the oscilloscope. These components provide various connection options and enable accurate measurements. Number 7. Control panels. The command center of the oscilloscope. Control panels offer knobs, buttons, and interfaces for precise control and customization of measurements. Today's oscilloscope displays can represent data in various ways, including Number 1. Waveform views. Traditional line-based representations of voltage or current over time. Number 2. 3D and color views. Utilizing color and three-dimensional rendering to represent additional data dimensions, such as intensity or multiple channel overlays. Number 3. On-screen measurements. Modern screens often display key measurements and statistics directly on the screen, offering real-time insights without the need for manual calculations. Do you think the oscilloscope is an accurate device to measure electronic signals? Will this help the electricians or engineers find if the appliances are in good condition or not? What is the importance of using oscilloscope in our industry? For the lesson activity, describe the characteristics and physical features an oscilloscope have that you observed from the video clip presented earlier. Write your positive description in an addition shape and write your negative description in a subtraction symbol. For the ampere meter, an ammeter, abbreviation of ampere meter, is an instrument used to measure the current in a circuit. Electric currents are measured in amperes. An ammeter is a measuring device that measures the flow of current in a circuit. It gives the exact reading of how much current passes through the conductor. Ammeter is derived from the Greek word amps, which means current. 4 applications of an ammeter. Ammeters are the current navigators in a variety of situations. From home to industry, they silently play a crucial part in maintaining a balanced current flow and enhancing our electrical experiences. Let's take a look at their applications. Number 1. Home wiring check. Ammeters lend a hand in confirming if your home's electrical system is running smoothly. By measuring current flow, they ensure that circuits aren't overloaded, averting potential problems. Number 2. Gadget performance. By hooking up to devices like your computer or fridge, they unveil their power consumption details. Number 3. Car troubleshooting. Behind a vehicle's dashboard, ammeters can uncover if the battery and alternator are matched perfectly. Too much or too little current can point to issues that need fixing. Number 4. Industrial bus. Ammeters are like stage managers in factories. They keep tabs on the currents feeding heavy machinery, guaranteeing a smooth performance. Number 5. Renewable energy setup. Ammeters can help us monitor and optimize the energy harnessed from solar panels and wind turbines. Number 6. Electronics creation. They can help fine-tune the components, ensuring they consume the right amount of current. For the types of ammeter. Number 1. Analog ammeter. The pointer inside the ammeter moves within a span of 90 degrees. The tip of the pointer corresponds to a numeric value. Number 2. Digital ammeter. It measures current flow in amps and display current levels as per the number of digits provided on a digital display. On using the ammeter, Follow the basic steps using ammeter correctly and safely. Number 1. Choose the right model. Do you need analog or digital? Do you need high or low capacity? Number 2. Before you begin, make sure that all equipment is used has been checked thoroughly for any faults. Use insulated gloves to protect you from live electrical current. Number 3. Apply the ammeter leads to the target area of the point at which you want to measure the current. Use a crocodile clip. Attach the red lead to the wire nearest the positive terminal and black lead to the wire nearest to the negative terminal on the device you are measuring. Number 4. Check your reading. On analog panel ammeters, look for the nearest marker to the needle. In measuring small amount of current using ammeter, Step 1. When operating on the 50 microampere range, we utilize the 0 to 50 scale and read the scale directly. Step 2. To read current in the 2.5 milliampere range, read the black 0 to 250 scale and move the decimal point 2 places to the left. Step 3. If the instrument is operated on its 25 milliampere range, read the black 0 to 250 scale and move the decimal point just once to the left. 4. When the multimeter is set to its 0.25 milliampere range, read the black 0 to 250 scale and move the decimal point 3 places to the left. Observe correct polarity of the instrument when measuring DC current. Be very careful against overloading your meter. If you are doubt of approximate reading, always start with the highest range. If the pointer deflects lefts across 0 point, just reverse the connections. No damage to the meter if this occurs. By peers, students will demonstrate the proper way of measuring amperes using multimeter. For lesson activity, determine the electric current reading on the ammeter below and indicate its unit of measurement. Number 1. Number 2. Number 3. Number 4. Number 5.